Hey, welcome back. This is week 12 of our graduate statistics course at the University of Cincinnati. This is the lab portion, and we're going to go over the last piece where we learn how to make predictions using the equation we just obtained from the regression analysis. Here's our equation. You know how to do it by hand. You learned it in the lecture piece. But let's learn how to program it up. All right, so when making predictions, the first thing, it's important to know the range of values of the predictor available in the data set to avoid extrapolation. If you're like, what? I don't know what you're talking about. Go back to the lecture video. It's important to watch it because I talked about it there, right? If you're trying to make a prediction using a value of ice cream consumption that's not in the data set, that's not in the range, it doesn't need to be in the data set, but you don't want it to be out of the range of the data set because then you're doing extrapolation, right? And I explained there why that might be a problem. So if you get the range of ice cream consumption, we have somewhere between 2.12 and 7.4 liters of ice cream a week, whatever you want to think. It's fake. But I know that I need to choose values between 2 and 7 because I don't want to try and predict the happiness of somebody that has 12 or that eats 12, 13, 14 because it's not in the range of the data. So we can ask, what is the expected happiness? Oh, this is mixed with the homework. What is the expected happiness of a person who eats 2 ice creams a day? How about a person who eats 7? To make predictions, you will have to follow 2 steps. First, you get the model slope and intercept from the model here, and you can save it into objects. You can name them whatever you want. So I'll name intercept for happiness, and I'll put there whatever the intercept is, 2. Hang on. It's good that I did this with you guys because then I can find all of my errors. Or most. Okay, so I recorded from here. This is where I grabbed. I grabbed the intercept, put it there. You can just do 2, really. And I grabbed the slope, 0.6. You have to run it because you need these values here to plug in things. Now, second step is to write out the equation of the line, y equals mx plus b, and replace b with the intercept value and m with the slope value. Then you replace x with the value of the predictor. Here, ice cream consumption, 2 or 7 or whatever number between 2 and 7 that you want. So here is, let me predict the happiness for someone who eats 2 ice creams a day. So I'm doing my equation. This is y predicted. This is y equals b, I'm getting this value, b, plus mx. This is my m. This is the slope, m, times x. What's my x? My x is 2 in this case. Right? I have to do the times. I should do this here in the same order that I'm doing it there for. This is the little sign for times. You need to get that in. And then I'm asking R to output that prediction. And then I'm saying also do this for, let's predict the happiness of somebody with 7 ice creams consumption. So I'll put the intercept, which is the same. I'm using the same model to predict, same equation, but I'm just going to plug in a different number. I'll plug in 7. And I'll ask R to output that. When I do that, I can see that somebody that eats 2 ice creams a day will have a 3.2 happiness level, and somebody that eats 7 will have a 6.2 happiness level, which is expected because it's expected to grow by 0.6 by every unit of change. Here we're changing 5 units, right? So let's see, we're changing 5 units, which means that's 5 times 0.6. Oh, let's type this in the console. Let me erase here. So I'm going to play with this. This is not going to be in your thing, but just to show you what this means. So we're what the slope means is that for each unit change in ice cream consumption, I expect a 0.6 change in happiness scale. So here we're seeing a 5-point change. So let's see if these things are mapping up and making sense. So 0.6 times 5, because it's 0.6 for each unit change, and we changed 5 here. Let me call this a particular name and ask R to output that. If I run, so we expect a change of 3, and look at that. It changed from 3.2 to 6.2. What's the difference between these? 3. So somebody that eats 2, somebody that eats 7, the difference between them is expected to be about 3, right? Because there's a 5-unit difference in ice cream consumption. So we expect 3-point difference in happiness, because for each unit change, we expect a difference of 0.6. All right. This is it for today. Please, you are gonna be working with a real data set in the independent activity. Please read the problem, because I will want to teach you a little bit about how to interpret and look at the scatter plot, thinking of the context of the problem you're working with. All right. I'll see you again, hopefully Wednesday, some of you, but if not, you'll see me at least next week. We're almost there, guys. Hang in there. Bye-bye.